and welcome to Geeks for Geeks. Today we would be discussing the problem find pairs with given sum in a doubly linked list. So in this problem we are given a sorted doubly linked list of positive distinct elements, and the task is to find pairs in doubly linked list. So what do we mean by this? This means that a sorted doubly linked list is given and you would be given a target, and we need to find the pairs which sum up to this target. Now let us evaluate the sample test case. Suppose you have the target as 7. So in this value 1 and 6 sums up to 7, and then 2 and 5 sums up to 7. So now how to solve this problem? Now to solve this problem, what we can do is we can take up all the elements and keep it in an array. Suppose we have here as 1, 2, 4, 5, 6, 8, and then 9 itself. Now what we can do is we can use 2 pointers over it. 2 pointers is a prerequisite here. I suggest you to learn 2 pointers first and then come to this video for in-depth understanding. I would explain you 2 pointers in general. So suppose we have the sum as 7. So as the array is sorted, we would have a pointer here, have a pointer here. So 1 plus 9 equals to 10. So if 10 is greater than 7, so we need to lower down the value. So what we would do is we would lower down the value. So we would come here, because we know that 1 if went to 2, it would higher the value. So if we want to lower down the value, that means this pointer should shrink from here. Okay, so we are just shrinking pointers from this to this, making it small. So at which side we should make it small? So if the current value is greater than the desired number, we need to make it small. So if we make this go this side, then the sum would increase. So if we would make this to this side, then the sum would decrease. So if we want to decrease the value, we would make this go this side. So now the sum is 8 plus 1, that is again 9, which is greater than 7. So again we would need to decrease this. So now 1 plus 6 equals to 7. Okay, so now this is there. So as we are told, we need to find all the pairs, okay, and they should be distinct. So 1 and 6 can't be used again. So what we would do is we would make this 1 move forward, as well as 6 also move forward. That is, these two numbers have been processed. Now we have 2 and 7, and this is equal to 7 again. So now this is also processed. So we come here, this is also processed, we come here. Now at this point, both is pointing to the same direction. So even if it sums up to this value, then it is not a pair because only single number is there. Okay, so make sure you have the condition that left should be smaller than right. That is, suppose the value is 8. Suppose the value is 8 and both the pointers are pointing at 4. So at this condition, both pointer would sum up to value 8, but it is not a pair. Okay, so to have this condition satisfied, we would have that condition statement. The time complexity of this 2-pointer technique is big O of n, and the space complexity is again big O of n, because we are using an auxiliary array to store all the elements itself. Okay, so now can we do better than this or not? Yes, we can do better than this. So if you see, we have a pointer to the first and we have a pointer to the last, and then this pointer is going to next value, this pointer is going to the previous value. So next and previous, we can do that in a doubly linked list, and it is already sorted. So that means we don't need to have the elements in an array and then sort it. This is also not required. The two requirements are that we need to go previous and next. It needs to be sorted. And after this condition, this is satisfied. So yes, this can be done. And one more thing that is there is, in an array, we can directly go to size -1 and we would have the last pointer. But this thing is not there in doubly linked list. So what we would do is we would go to very last pointer this and this, and we would make it go from this to this to this, and this would be done. Okay, so now let us summarize everything that we have learned. So what we would do is, we know that we are given a sorted linked list and we need to find positive distant elements. So we would use two-sum technique directly on the given linked list. And if two pointers is pointing to the value that is value, then we would shrink it. Why? Because that two value have been used and we need to find distinct elements. Okay. So now let us move to the implementation and you would have a better understanding. Now, what we would do is we would have two pointers. The first one would be the left and we would name it with head, and then one more as start right, and it would also point to the head initially, and then we would try to make it go to the last value. Okay, so what we would do is, while right dash next is present, we would keep moving right forward. R is equals to R dot next. And then we would have the vector of pair of int and int, and we would name it with res. And then what we would do is, we would start shrinking it. That is, while left is not equal to right, and right dash next is not equal to the left value. Suppose we have R at this side and L at this side. So now suppose after this point, R would go to this side and L would go to this side. Suppose it has satisfied this condition. So after this point, R would come here and L would come here. So if there are even elements, that is this and this, then after this point, this one would be here and this one would be here. So that's why we are telling that R dot next is not equal to L. This condition should also be not there. Okay. I hope this thing is clear at this point. And we would have the sum as L dash data plus R dash data itself. Okay. So now we would say that if this current sum is equals to the target value, then we would say ans dot push back. Okay. L dash data and R dash data itself. Okay. And then this is done. After this point, we would make L is equals to L dot next and R is equals to R dash previous. Okay, fair enough. Then we would have the next condition, that if the current value is less than the target value, that means we need to increase the value. To increase the value, L should move to the right hand side. Okay, so I would just show you this also again. Suppose we have 1, 2, and 3. This is pointing to this, this is pointing to this. If we want to increase the value, then this pointer should go from this to this. That is why if this is the condition, then we would make R is equals to R dot next value. Okay, and else condition would be when sum is greater than R, then this 3 from 3 we should go to 2. So we would say that L. So if the sum is less than target, then we should move the left towards the right side. So 1 should go to 2. From 1 we should go to 2. So we would say that L is equals to L dash next value. Okay, and else condition would be there when sum is greater than the target. If sum is greater than the target, then from 3 we should go to 2. That is, we should lower down the value. So we would say that R is equals to R dash previous itself. And then it's done. And after this point, we would return the answer. Let us just compile and run and see how many errors are we making. We are not making any errors as of now. We got accepted. And talking about the time complexity, a time complexity remains the same. That is big O of n. So if you were here till this point of the solution, consider liking the video and commenting on the video with a 1 or understood or your feedback, so that the reach of this video could be increased. Thank you and have a nice day.